Hello everyone, and welcome to Solving for Expected Ground State Electron Configurations. Today we will be reviewing 4 sample problems and determining their ground state electron. A. The element with one unpaired 5p electron that forms a covalent compound with fluorine. Okay, so here we are told that this element is found in the p block and in the 5th quantum level. So right here. In addition, we are told that it must form a covalent compound with fluorine. Therefore, we know it cannot be a metal because then it would be an ionic compound, not covalent. Lastly, and most importantly, we are told it has one unpaired electron. Therefore, the element in question could be either indium with 1 p block electron or iodine with 5 p block electrons. However, we know it cannot be indium because it cannot be a metal, like I stated previously. Therefore, the element in question must be iodine with a ground state electron configuration ending in 5p5. So, we know that it's going to end in 5p5 because there's 5 electrons that it has in the p block, which can hold 6. 1, 2, 3, 4, 5, 6, into the 5th quantum level. So, using this table, we can go back and write out the abbreviated electron configuration ending in krypton. So, we'll put krypton over here. Using this table right here, we can go diagonally, so this way, to figure out the numbers in between. So 5p to 4d, and d can hold 10, and then going from 4d back to 5s, which will bring us all the way back over to rubidium, and since it has filled all the way up to iodine, that is also full, ending in krypton. So there it is, iodine electron configuration. B. The as yet undiscovered alkaline earth metal after radium. This one is actually quite simple. We are told that it is the not yet discovered alkaline earth metal after radium. Therefore, all we need to do is take the electron configuration of radium. So when we do this, we can use radon as the abbreviation. And then 7, because it is in the 7th quantum level. S2, because it fills the s orbital. So, theoretically, the next one would be right here. Except for this electron configuration, we're going to use this element, this new element, as the abbreviation instead of radon, because it is down at quantum level. And now it is in the 8th quantum level, still with the s orbital filled. And that is your answer. C. The noble gas with electrons occupying 4f orbitals. Okay, so essentially what this chart does for us, that I've written out here, is it shows us the order in which the quantum levels and blocks appear during electron configuration. As we move diagonally down from right to left, we form the pattern of electron configuration. Therefore, when we have a noble gas, meaning it ends in p6, so the ending is going to have p6, because it is in the last column of the p block, and it passes through the 4f orbital, we can simply trace it backwards. So, we have the 4f orbital here. We know that it is going to be filled because it has to go to p6. So, from 4f, we go to 5d. We know that that d orbital is filled as well, going from 5d to 6p. Okay, so, but we have to write out the full ground state electron configuration. So we're just going to go backwards from 4F down to 6S. We know that is filled as well. So now we're going to look at the chart, go down 6, because this is the 6th quantum level, 1, 2, 3, 4, 5, 6. Goes back to xenon. So we can abbreviate that. Xenon, 6s2, 4f14, 5d10, 6p6, and that is the element radon. D, the first row transition metal with the most unpaired electrons. Okay, so lastly, here we are asked to find the first row transition metal with the most unpaired electrons. Immediately, we know that it is in the 3rd quantum level and it must have a D block subdivision, because we are told it is in the first row of the transition metals. So looking at the periodic table, first row of transition metals is right here. And it is in the 3rd quantum level. See that here. So we know that it's going to end in 3D. Now, we just need to find the element with the most unpaired electrons. Well, using a little diagram, we can find this quite easily. Since elements in the D block can hold 10 electrons and have a minimum of 5 pairs, we can illustrate this where 5 dashes, where 2 electrons are held in each dash, we will have abbreviated the electrons as an arrow. Therefore, in order to have the maximum of unpaired electrons, each dash must have one arrow but not another. So it's not paired because there's not 2. We'll illustrate this as arrow, 1, 1, 1. So now you have 5 unpaired electrons filling each of the 5 possible pairs for 10 electrons. Using this method, we can assume that the element in question is manganese with an electron configuration ending in 3d5. Okay, now we're just going to retrace our steps using the chart. So we end with 3d5. Going backwards, we're going to find ourselves at 4s, and since we have to get to 3d, 4s is filled. Now looking at the periodic table, we go down to 4s right here, and we're going to fall back to argon, which will be our abbreviation. And that is for the element of manganese. That is your answer. Okay, that is all for now, folks. I hope you enjoyed this video and learned how to identify ground state electron configurations based on given information.